Alright, welcome. I am just going to flip through the first couple slides in case you want to pause and see what we did. We're going to zoom ahead until we reach the lesson. Here's a reminder. To begin with, let me find my shape tool. Alright, should work. Remember how we talked about how some numbers are perfect squares? Let me fix that one a little bit. There we go. So there's a square. It's covering up 9 boxes, right? The easy thing to see is that the side of that square is 3, right? So if we wanted to say it, we could say the square root of 9 equals 3. And we call it a perfect square because the number of boxes that fits into the square is the number that we have fits exactly into a perfect square. Okay? We can even label the number line. Let's say that this is 0, and this is 10, and this is 20. The square root of 9 fits right here. Square root of 9, same thing as 3. Throughout the next couple of lessons, you'll notice that I'm going to have some equations on the side which show that the square root of 9 is the same thing as 9 to the 1/2 power. Fractions, or exponents that are fractions, can be written as square roots. Okay? And we'll develop this a little bit more. We are going to be doing most of our work using the square root sign, the radical sign, but you should know that that's the same thing as 9 to the 1/2. All right. So we already talked about perfect squares. Now the question becomes, where does a square of 8 fit in? Can you make a square that has 8 blocks in it? No, it won't work. But you can see that we know that it's going to be somewhere in between these two, right? So what we're going to do is, you know what, let me actually move this square over, and let me make a square that's going to be middling in size, right? So let's label these. This is 4, and the square root of 4, equals 2. This is 9, and the square root of 9 is 3. This is 8, and the square root of 8 is going to be somewhere in between 2 and 3. You can see that it's 2 and a little bit more. So on a number line, we could put square root of 2 right here. Square root of 4 right here. This would be radical 4, exactly. And this would be radical 9, or square root of 9. Square root of 8 is going to be somewhere in here. Do you think it's going to be closer to square root of 4 or closer to square root of 9? Probably closer to square root of 9. I'll put it down below. Square root of 8. These two are called perfect squares. This one, imperfect square. Okay. In your own words, please write down what you think a perfect square is and what you think an imperfect square is. I would say a perfect square is a number whose square root is an integer. Okay. imperfect square would be a number whose square root is not an integer. It could be a mixed number, like 2.5. It could be an irrational number that goes on and on and on and on forever. As an aside, if you took 2 and plugged it into a calculator along with a radical sign, you took the square root of 2, you would get an irrational number that goes on and on and on and on forever. All right, your turn. Try and find the square root of 21. Okay? First, I would say on one side, I know that 16, see if I can get that to be pretty perfect. 16 is a perfect square, and the square root is 4. On the other side, I've got, oops, I need my tool. 1, 2, 3, 4, 5. Okay, that would be 25. So on this side, let's move this over. We've got 16, and the square root, shoot. And the square root of 16 is 4. On the other side, we've got 25, and the square root of 25 is 5. We know that 21 goes somewhere in between here. So the square root of 21 is going to be something like this. Make it a little bigger. Something like that. Where 21 is here, the square root of 21 is going to be somewhere in between 4 and 5. So on my number line, if this is 0 and this is 10, I would count up 1, 2, 3, 4. Here is square root of 16. Here is square root of 25. And right about here is the square root of 21. All right, the square root of 15 is going to be somewhere in between what? Think of perfect squares on either side. Well, we know it's going to be smaller than the square root of 16, and we know it's going to be bigger than the square root of 9. I chose those because those are the perfect squares that I know on either side. So if this is 0, and this is 10, square root of 15, well, square root of 9 is right here. That's 3. Square root of 16 is right here. That's 4. And the square root of 15 is probably right about here. If you put it in a calculator, you're going to find an irrational number. Now give this your best shot. Think of the square root of 53. Tell me what number down to the 10th place you think it might be. Just estimate. Here's how I would estimate it. I'm thinking of perfect squares on either side. Well, I know that square root of 49 is a perfect square. I know that square root of 64 is a perfect square. This is 7. This is 8. So this is probably somewhere in between. I would guess 7.3 maybe? As a guess? Let's see. Oh, I was right. Let's try this one. What do I know? I know that the square root of 144 is 12. Do I know what the square root of 13 is? What is 13 times 13? 9, 3, 9, 169. Oh, well, it's got to be bigger than that. Square root of 16 is, let's see, this is 13. Let's try 14 times 14. Oops. 14 times 14, 16, 540. That makes 6, 9, 196. That's the square root of 14. So I know that this has to be somewhere between 13 and 14. I'm going to guess something low because this is kind of close here. I would say 13.1. Yeah. Let's try this one, a little bit easier. What are some perfect squares on either side? Well, I know the square root of 64 is 8. And on the other side, I know that the square root of 81 is 9. So this has got to be somewhere in between. Let's guess 8.2? 8.3, pretty close. All right, what did you learn today? You learned about, imperfect squares. What makes a square imperfect? Well, the square root of it is not an integer. Okay? Good luck with this.